Hey fellow statisticians, Miles here. Gonna tell you about my final project where I'm looking into how favors decay over time. So this idea comes from favor economies. People study favors and reciprocity. We want to understand how the value of a favor changes. We're considering the value of a favor to be the probability that someone reciprocates on that favor. So we hypothesize that it'll decay with time, but that the strength of this decay, the rate of decay, will be lesser for higher cost favors because people are motivated by indebtedness, as opposed to higher benefit favors, even though they seem like they create more value, they might have a lesser rate of decay, um, or a stronger rate of decay. So this is an image from how we studied this. Subjects read vignettes of favors. They were in several different time conditions, either reading that it's a day later, a week later, or a month later. There are also two different versions of the scenario that every subject sees. And the subject will see the original scenario, and then later they'll answer the question again for a modified version of the scenario that's either been increased in benefit or increased in cost. So there are a lot of different levels going on here. Kind of signals some hierarchical structure, but we also want to be able to regress reciprocity onto time, which is our overarching effect. So this is the hierarchical regression that we're interested in. You ready for this? This is simple linear regression, but there's some stuff going on here, right? We want the random effects that are shown in that diagram on the left, where it gives us both the ability to have different intercepts between groups and also the ability to have different slopes. The different intercepts reflect the different value, the different initial value of the favor, while the different slopes reflect the differences in the rate of decay of the particular favor. We capture that in the model with both terms for the modification, but also interaction terms that let that slope change. Here's the key. If we want to get at the underlying effect, but we have two different scenarios, we actually have two different copies of that same model, a hierarchical version of this regression, where for a given beta, let's say beta 2, there's the beta 2 for scenario 1 and the beta 2 for scenario 2. We assume that they're from the same distribution. So this kind of hierarchy in linear regression gives us the ability to generalize beyond what's specific to the individual scenario and get a clearer picture of the underlying phenomenon. I'm excited to share results, but you'll have to come to the poster session to see them. Take care, everyone. See you soon.